Hello and welcome to this video on quadratic sequences. In particular, this video is going to make sure that you are able to identify when a sequence is a quadratic sequence and to be able to determine the nth term rule for that quadratic sequence. So here we have a question from an exam paper about quadratic sequences, and they give us the first 5 terms of the sequence and we're asked to find an nth term rule for it. So when we actually are told that this quadratic sequence, what we're going to do is to write that sequence out and start looking at the term-to-term rule. How do we get from one number to the next? And as we go across this sequence, what we'll realize is that it's not the same each time, but there is a pattern in those numbers that it goes up in. So 7, 9, 11, 13, we can see that those numbers are going up in 2. Now this value of 2, which is called the second difference, is important. We're going to use that later to find our nth term rule, but all quadratic sequences will have a common second difference. It will stay the same. And what that number is important for finding your nth term rule for a quadratic. So when you're finding the nth term rule for a quadratic, the difference between that and a linear sequence is that it will contain an n squared term. And there will usually be a number at the front multiplying that n squared. That value is half the second difference. So whatever you found your second difference to be, halve that, and that is the value that multiplies the n squared term of the rule. So the nth term rule will have 1n squared, or what would be far neater is just n squared, as part of that rule. The rest of that rule will be made up of a linear nth term rule, and we'll find that out separately. So I take our original sequence, and what I'm going to do is write out the sequence for my n squared part of the rule, and then I'm going to find the difference, and I'm going to see what it is that I have left. In doing that, what I find is that my remaining sequence should be a linear sequence, one which I should be able to find an nth term rule for a bit quicker. So if we look for the nth term rule of that sequence that remains, we will get 4n minus 1. It goes up in 4s, which is why it's 4n, and minus 1 would be the 0th term if I went back a term. There are other ways you can find that rule out if you don't already know. So to get a final answer, I need to add this new linear rule to the n squared term that I had before. So my overall rule, n squared plus 4n minus 1. And I can always check that by substituting in values of n. So this video has gone through some of the basics of finding an nth term rule for a quadratic sequence. Now, not all quadratic sequences increase, not all nth term rules that are afterwards are going to be nice, and there can be slightly more complicated problems. But this basic principle of how you solve this should be helpful in most standard questions. Hopefully this video has been helpful, and thank you for listening.